The 17th century witnessed two transformative developments in European history: the rise of absolutism and the First Scientific Revolution. The Scientific Revolution represented a fundamental shift in how Europeans understood the natural world. For the first time in centuries, science was re-examined with fresh intensity and curiosity. Although ancient civilizations had been deeply interested in scientific inquiry, medieval Europeans focused more on spiritual matters, particularly salvation, than on understanding how the physical world worked. But in the 1600s, science gained new energy and significance. Why did this happen? The honest answer is that historians cannot point to one single cause, but several widely accepted factors help explain this remarkable moment. First, the 17th century produced some of the greatest scientific minds in history. Many of these individuals worked alone or with only a few assistants, yet their discoveries were groundbreaking. Once published, their work inspired and enabled further advances, creating a rapid acceleration in scientific knowledge. Second, by this period, scientific inquiry had reached a point where discoveries could build upon previous discoveries. As we know today, major breakthroughs rarely occur in isolation. Increasing amounts of research and publication allowed scholars to examine existing data and draw bold, innovative conclusions from it. Third, the Protestant Reformation indirectly contributed to the rise of scientific thinking, not because Protestantism encouraged scientific discovery directly, but because the religious wars it inspired led many thinkers to question the value of theological conflict. After witnessing destruction and bloodshed caused by religious divisions, some intellectuals sought modes of thought that were not controlled by religious authority. Science offered one such path. A related argument suggests that the Reformation promoted science by reshaping attitudes toward work. Protestantism taught that all forms of labor, not just the work of priests, were spiritually valuable. As a result, talented thinkers no longer felt compelled to enter the church and write solely about salvation. Instead, they could devote themselves to studying nature. This helps explain why Protestant nations such as Britain and the Netherlands became leading centers of scientific innovation. However, this explanation is only partial. Not all major scientists of the era were Protestant, many were Catholic, so the scientific revolution cannot be attributed to a single religious tradition. It was a complex, multifaceted development shaped by great minds, accumulated knowledge, and the intellectual upheavals of the age. The first major thinker of the scientific revolution was Francis Bacon, who lived from 1561 to 1626. Bacon argued that, when examined closely, the learned men of his time actually knew very little about how the natural world worked. Their scientific knowledge was based almost entirely on the writings of classical thinkers such as Aristotle and later medieval scholars like Thomas Aquinas, who tried to build upon what the ancients had written. Bacon insisted that this was a poor way to understand nature. Instead of relying on old authorities, he believed that people needed to perform their own experiments, make direct observations, and reach their own conclusions. This approach forms the basis of the scientific method still used today. Researchers conduct experiments, carefully observe the results, publish their findings, and allow others to repeat those experiments to confirm the conclusions. Bacon referred to this process as inductive reasoning, in which many specific observations are used to build toward a broader general conclusion. However, there is one major field in which inductive reasoning does not work: mathematics. In math, we do not conduct experiments to prove that 2 plus 2 equals 4, or that parallel lines never meet. These are accepted truths, and we apply them to specific problems. This kind of reasoning, starting with general principles and applying them to particular cases, is known as deductive reasoning. The great champion of deductive reasoning during the scientific revolution was the French mathematician and Catholic thinker René Descartes, who lived from 1596 to 1650. Descartes believed that reality could be divided into two kinds of substances. First, there was the thinking substance, the world inside the mind. This included emotions such as joy, grief, and hatred, as well as sensory experiences like color and sound. Descartes argued that the very act of thinking proved our existence. This idea produced one of the most famous statements in Western philosophy: Cogito, ergo sum. I think, therefore I am. Second, Descartes identified what he called the extended substance, anything that could be measured in the physical world. He believed that anything measurable could also be expressed mathematically. This conviction led him to develop coordinate geometry, which connects algebra with geometric shapes and is still taught in schools today. Descartes believed that the universe itself could be explained through mathematics. He once said, "Give me motion and extension, and I will build you a world," meaning that if something occupies space and is capable of moving, it can ultimately be described through formulas and equations.